All right, Happy New Year, everybody. Today we are doing rational function, transformation, and asymptote. We first going to talk about transformation. In order for us to talk about transformation, we know there are three famous letters, A, H, and K. And doesn't matter what kinds of function you are, the A, H, and K are always going to follow the genetic formula. A, f of x. F of x stands for any family function could it be. For right now, our family function right now is irrational. And then we have A is going to be in the front, H in the middle, and K is in the back. The parent function, as we just mentioned, is irrational, and it looked like this. F of x is nothing but y, y equal 1 over x. So how can I build the formula based on this? I already write it down for you, but I feel like it should be easier if I also talk about it. So we know f of x is our y equal 1 over x, right? So in order for me to build the formula, I just have to put 1 over x. So that's the parent function. The letter gonna go in the front is nothing but a. The letter gonna go in the middle is going to be H. Knowing how H is always gonna go follow X, right? Because H affecting left and right, you know how the x-axis go left and right. So you wanna put the H, you don't wanna put right here. If you put it right here, then it doesn't go with X at all. It just go right in the middle of nowhere. So you wanna make sure that you put them right with the X. So you're gonna have the minus H right here. Sometimes you can put the parenthesis if you want. If the situation does require a parenthesis, then you can. If not, you can leave it like that. We talk about it when we get there. And then we have the letter K is gonna be in the back. Bam. And voila, you build your formula. So that's going to be just like that. A in the front, H in the middle with the X, and then K is in the back. Sometimes you notice how the ones is gone, because technically if you do A times 1, it's just A. But if you want to write them like this, it's okay. But again, if you want to multiply A times 1, give you A, you can also give you that formula. It's exactly the same thing. We're going to explore more as we go, okay? So here we go. So let's go ahead and take a quick look. I have two scenarios to give you. The first one, let's talk about it. So the first one we are doing, let me clear off this. The first one is that we are write a transformation, okay, based on the given equation. So in this one right here, we going to give you the equation and you're going to write the transformation, okay? So let's do it. And in a little bit, we're gonna do the opposite. We're gonna write the equation based on the given transformation, okay? Whatever it is, we're gonna get this done. So let's focus one at a time. So right now, we're gonna write the transformation based on the given equation. So this is the equation. Describe the transformation that occurred from the rational function f of x equal 1 over x, okay? So this is the rational parent function. You see how f of x is? And then they are transformed into g of x. Now, they just want you to list it out. You describe the transformation, so just list. I like to write the formula on top of it just so that I don't have to, I have something to like at a reference. So here, they want me to use the general formula, right? They just tell me to describe. So I'm just gonna use the general formula in order for me to do with it this one. Okay, so I'm just gonna write it on top of that. A, F, x minus h plus k. If I'm going to matching all of this, it's telling me that plus 4 is k. And I just have to look at my transformation rule. Plus 4, I'm going to go up 4. Okay, you gotta have your transformation rule out. That is the only way gonna help you, okay? And then minus 2, that's going to be, what do you think? I hear you say minus 2 is h. I love it. So here you go. That's telling me that we are going to the right too. Please use the transformation as a reference for you to do. Is there any number in front? Not really. So that we don't have any transformation on A. And then that's it. Pretty much done. Okay. Let's go ahead and do one more over here just to be sure. So we have A. I like to be the same color, so let's do A, F, X minus H plus K, just matching it. So here we go. I'm going to match in minus 3, it's telling me this is K. And when I have this, I'm going to go down 3. Okay. And then I'm going to try with +1. What one with +1 then? +1 telling me this is H. And when you add, you go to the left. Okay. And then finally, I have negative. Ooh, every single time you see negative, right away, you know that it's going to be a reflection over the x-axis. All right. And then we also have 1/3. All of these are A, right? So 1/3 compared to 1, it's a small number. So when it's small number, it's going to be compressed by 1/3. And that's it. So you are done by listing the transformation, okay? Now, how about the second type of the problem in which that they going to give you all the list, they listed out all the transformation for you, and you go in to write the equation. We can do this as well, okay? So let's give it a try. Given f of x, it transformed to create g of x, okay? So here we go. They said the translation 1 unit right and up to. Before you do anything, make sure you write out the formula first. So this is f of x equal 1/x, right? The genetic formula for transformation, see like this. A, f x minus h plus k. But we are building the formula based on our parent function, f of x. It's telling me this is 1/x, and I'm just gonna put the letter. The letter A always gonna go in the front. The letter H always go into the middle, so minus H, but with the X, okay? And the K is always gonna be in the back. You wanna extend it a little bit longer? Okay, so here we go. So let's go ahead and plug them all in. Translation right one. When you go to the right, what letter gonna affect you going to the right? That is H. And when you go to the right, you subtract. So again, I'm still going to have my transformation 1/x, right? And then this is 8. And we said that we're gonna go to the right. We're going to subtract, so -1. So I'm just gonna leave it like that. Up to, what one is up to? Up to telling me is K, and it's K's in the back. So I'm just gonna put +2. Is there any A's in the front at all? Not really, right? So I don't have it, and I just leave it like that and think that is my answer. So what answer choice are giving me that? Notice how sometimes they have the parenthesis, right? With or without the parenthesis, it doesn't matter. So if here we go. For this example, it doesn't matter. So we can put them. So the answer going to be D. Okay, boom. And we got that. You don't have to, but if you want to grab them, just to be sure, you can also grab them and double check your work. So what I can do right now is go into decimal, and I would like to grab it for you. So first, I want to grab the parent function first, 1/x. So have 1 divided by x, okay? So that's the parent function, you see the red one. I'm gonna grab the new function that we just created, so that's gonna be 1/, so divide, and then I put x minus 1. And then I wanna go up here and I'm gonna put, as you can see, x minus 1, they go to the right 1 unit, right? You can see that the graph shift to the right. And then I'm gonna put +2 and the whole graph gonna go up 2 units. So that is how you're looking at it. And that means you are correct. You don't have to grab them unless you want to, but to be safe, you always wanna check if you want to. Okay, so here we go. Okay, so what we're going to do next is the second, the second example of the type. Again, we are writing an equation based on the given transformation. So given f of x again, I will start f of x. This is the parent function. We always start from our parent. So here we go. The generic formula is, a f x minus 8 plus k. It's telling me that I'm using f of x, so I'm just gonna build my formula. But really, guys, I don't have to memorize. I just have to remember the letter A on the front, the letter H go the X, and the K is in the back, just like that. Now, let's go ahead and build what we have. You want to build a snowman? Not in Texas, but yeah, we're going to build an equation instead. So reflection over the x-axis, that's this A, right? And we know the sign is going to be a negative sign. So I'm just going to put a negative under A. Vertical stretch by 3/2. I know that's also A, so I'm just going to put under A. So 3/2. All right, here we go. I'm going to have 1/x. I'm still going to keep it like that. And you go like, oh, so what do I put between D? Do I just put it like that? I would highly recommend just put a multiply if you want, because, you know, your number in the front, that's technically a multiplication. So I'm just going to put a multiply just to be safe. And then translation left. When I go left, it's telling me that's the H, and I'm going to add. So I'm going to plug 3. And then I'm going to go down. It's telling me this is K. So I'm going to -1. And I'm pretty much done with my example. Here, I would like to talk to you about the parenthesis. In this case, it's important for you to have the parenthesis because -3/2 I'll multiply with this whole thing, right? So if you don't put the parenthesis, so you want to put a parenthesis right here. The reason is, if you do not put a parenthesis, when I put -2 times x plus 3 without a parenthesis, -2 only multiplied to x, but it's not true. -2 are multiplied for the whole group. So you want to put a parenthesis here. Okay, and then also, as you can see, you multiply the bottom and then the top. 3 times 1, if we write it like this, it looks like a 31. So you also want to simplify to 3 times 1, going to give you 3. So -3 on the top, and then 2x plus 3 minus 1. Simplifications is important because, you know, it looks less complicated. Again, one more time, 3 times 1 is 3. And then we have 2 with the parenthesis because I'm technically distribute this for all of them. So this is when the parenthesis come in handy, and it's important to have that. Anyway, what answer choice that have that answer? That going to be, sometimes we have a hard time looking for the answer, huh? It's gonna be C, right? All right, I highly recommend you to grab them just so you can see the transformation for yourself. So let's go ahead and do it. So 3/2x, the graph are reflected, the graph got more stretching. And then we also have the parenthesis right here, and we're gonna do a +3. It's gonna go to the left 3 units that you see, and then it's going to -1 and gonna go down, okay? So again, you don't have to grab only unless you want to, just for yourself to see, okay? All right, so we just get done with transformation. So what we're going to do right now is going to be vertical asymptote and horizontal asymptote. So what is a vertical asymptote and what is a horizontal asymptote? So let's talk about it. You know, when I first teaching this, I have a hard time spelling it out, and it's just a difficult word. But anyway, vertical asymptote, think about something that go vertical, that stop you. So imagine you like a car, right? Okay. You're going this way, boom, 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 but it stopped you. So you can't go past this because it's like it stopped you. So the only thing you can do is just riding along. Like the car can only ride along here, but it cannot pass it. So we call them a vertical asymptote. Think about an electric fence. You don't want to hit. You can come really close to the fence, but if you hit it, you're gonna get shocked, right? So you don't want to pass that. Now, and then we also have a horizontal asymptote, and it go like this. It go horizontally. So think about an airplane. Okay, it look like a well. So an airplane fly, but they can't pass this because there's something stop you from up here. But anyway, so that is a horizontal asymptote. You can fly along, but you cannot pass that. Okay, and one way for me to remember a vertical asymptote, vax, like vaccine. And then horizontal asymptote, hey, like, hey, how are you? Hey. and it's gonna be y. What does that mean? Let's talk about this. I'm gonna give you several functions, okay? What you're going to do is grab them in the calculator as simple as this. And you're gonna have the same picture like the one I already grabbed, but I'm still gonna show you just so to make sure that we all see the same thing. So I'm gonna grab question number 5. So I have negative 5 over divide. So here we go. I want to explain all the backs and hay. It's a little thing to have you remember. Plus 1. And then when I get out right here and do minus 3. Okay? Okay. So as you can see, we have the same thing we have over here, correct? We have the same picture, right? I just copied the picture over, so I'm just gonna exit out this one. So imagine if I'm gonna have a vertical line right in between, that separate these two graphs into two parts. So that imagine is gonna be this line, right? Okay, so looking good. So the line right here, let me draw with a thing. So the line, oh, it's not straight. Let me try again. So I'm gonna have a vertical line go through right here. Do you agree? Yeah, I think you are. You say yes. The line right here is vertical. So you see it's vertical because it's go vertically. And why we set backs? Because it crossed through the x-axis, right? It crossed through the x-axis right here at x equal how much? Vertical asymptote, backs, x equal 0 to see negative 1. That's it. So I will have a vertical asymptote at x equal negative 1 because this is my car. My car are driving. I can go past this. I can go past this because it stopped me. So the only thing I can go is to go along here. Same thing, I'm gonna have my cars again. I'm gonna travel it, I'm traveling. I can't go past here, so the only thing I can go is this. Well, car doesn't go up like that, but let's just imagine. Maybe I'm gonna bring my airplane back. But anyway, that's the vertical asymptote, okay? Vertical, x equal. Do you think we're gonna have a horizontal asymptote in this example? Can we? Again, the trick is draw a line in between. Draw a line in between. Let me put the slide back first. Okay, so the trick is, let me write it down. You hear me out. You have to draw a vertical, horizontal line in between. Just find the lines in between the graph. You will see it. Just look for in between, okay? So here we go. So that's the little trick. Remember that? Okay, so here we go. I'm going to draw a line in between the two. And the line gonna go horizontal this time. So I'm gonna draw this line. So here we go. I'm going to have this line right in between. And it's going to cross through y-axis this time, you see? Horizontal. So it's horizontal because it's go horizontally and it's gonna be y equal how much? 0, -1, -2, -3, -3. So that is my horizontal asymptote and that's my vertical asymptote. So that is how I find it, okay? So let's try with this picture. Imagine you're gonna grab them, okay? You're gonna type it in the calculator exactly the way they look. So first I'm gonna looking for a horizontal asymptote. So again, I'm just gonna see this either grab 1, grab 2. I just draw lines in between. So the lines in between, as you can see, why don't you pause it right here and you tell me the answer? I'm gonna see a lines in between right here, right? Bam. And it's going to be hey, because it's horizontally. Hey, how are you? It's gonna be y equal, and it's gonna be -4. Okay, how about a backs? I'm gonna draw a line between these two graph 1 and 2. So I'm gonna draw a vertical line in between. The only vertical lines in between that I can see is this one, bam, right in between. And it's going to be backs. Vaccine, so here we go. B-A-X, backs, x equal. It's gonna cross through x-axis. Where x-axis? Right here. Oh, x equals 0. You see? Very simple, right? Hope that makes sense to you. We have 2 more and then we are done with the day. So let's give it a try. Number 7, number 8, again, you're going to grab them in the calculator in decimal in order for you to see them. I'm gonna draw lines in betweens again. So here we go. This is my grab 1, grab 2. They have 2 parts, right? If I'm gonna draw horizontal lines in between, the line gonna go like this. And it's gonna be a K and Y equal. You have to look for where it crossed through the Y-axis. So here we go, Y equals 0. Again, it crossed through Y-axis, my bad, as 0, okay? If I can draw a vax, a vertical line, and it in between, so it's gonna be somewhere here, correct? I think I need to use the other two. It's not straight up, but you know what I'm talking about. So this is gonna be a vax. Why is this a vax? Because it crossed through the x-axis at this point on the x-axis, and its x-axis happened to be 0, -1, -2, so vax x equal -2. Okay. All right, this time I'm just gonna use the line. Okay, so I'm gonna draw a vax. Let's go through, separate here between, boom. Oops, it's not as straight. Okay, so this is my vax. Why this is a vax? Because it crossed through the x-axis at x equal 1, okay? So x equal 1, vertical, x equal 1. I'm going to draw a horizontal line between this. So it's gonna go like this. Oh, I'm supposed to use a ruler, but it's okay. You got the picture. It's gonna be a horizontal because it's a horizontal line. It goes sideways and it's going to cross through the y-axis. So hey, y equal -5. Okay, so that is how you find asymptote, vertical asymptote and horizontal asymptote. As you can see right here, I would like to show you a little trick to this, just a little secrecy, because you've been watching this video all the way here. I would like for you to take a quick look. You see how the horizontal asymptote right here, look at this number. I go down 5 units, so that's why my horizontal, it has something to do with K, because I go down 5. So my horizontal asymptote, because I go down, you know, so it's gonna be on -5. Now, if you look at the vertical asymptote, I go to the right 1. You see, I go to the right 1 unit. So that's why my vertical asymptote at 1. Check it out. Right here, I go to the left 2 units. So I have a vertical asymptote at -2. Here, I don't go anywhere at all. They know K. I stay where I am. The parent functions is always stay from the origin. Because the parent functions always stay from the origin. So nothing changed in the parent function at the origin at all. They always start from 0. But here, since they know K, that's why my horizontal asymptote is 0. Just a little thing, observation. If that interested you, I hope you use it. But if not, no worry about it. Okay, take care. Thank you so much. And I hope you have a wonderful new year. Bye-bye.